All right, pretty easy day here. Shh, y'all be quiet. Pretty easy day here. Roots and powers is what we're looking at. A lot of this stuff you'll be able to do in your calculator. We're going to go through the steps though. If I asked for the cube root of 27, okay, the cube root of 27, just a reminder of what this is actually saying. Whatever root it is you're taking the third root, that means I'm looking for what times itself 3 times equals 27. Okay, so what times itself 3 times will give us 27? 3. Very good. So this would be a time we're going to be doing lots of squares and cubes and stuff. So now, to get a cube root on your calculator can do that. You got to hit math and move it down to the one that's got a 3 in it. Okay. All right. This one asks for the cube root of 216. So what times itself 3 times equals 216? 6 is correct. Okay. Now both of those were cube roots, and that's an odd number. That has a lot to do with the signs, if our answer is going to be positive or negative. If it's an odd root, your answer, positive or negative, will be whatever's underneath there. This was a positive 27, so my answer was a positive 3. This is a positive 216, so my answer was a positive 6. I could do the cube root of negative 27. That would be negative 3. Okay, I could do the cube root of negative 216. That would be negative 6. All right, but when we go to an even root, bless you, I want the fourth root of 256. All right, what times itself 4 times equals 256? It is 4. Good. Let me tell you how to do that on your calculator, because this one requires extra buttons. When the root is higher than 3 from your home screen, you got to push that first. So I'll push 4, then math, then move it down to the one that's got an X in it. Okay? But now this is not my complete answer. This says that 4 to the 4th equals 256, and it does. But negative 4 to the 4th will also equal 256, won't it? Because a negative times a negative times a negative times a negative is a positive. So my actual answer, good Sydney, would be plus or minus 4 on that.
Are we about to get into imaginary numbers?
Not today, but we're getting there.
Don't. No, I'm going to put that one.
Okay, if I had that same deal there, the fourth root of negative 256, now this is what Leo was just asking about. We remember from Algebra 2 that that's actually going to be an imaginary number, but for today's stuff, all we have to do is say that is not real. Reason that's not real is you can't take a number 4 times and get a negative. If it's an even root and you do an even power, that's always a positive. And we'll get into the imaginary stuff later in the week. Alright, when we got a fraction underneath our radical, remember the radical is just a fancy name for the root symbol? I've got a fraction underneath our radical. I've got the fourth root of 16 over 81. Okay, when that fraction's underneath there, that means you take the fourth root of each of them.
So
2 over what?
it would be 2.
Over 3. And then since this is a fourth root, that's an even number. It could be positive or negative. Am I good on that?
So it's an even group, and it's always going to be plus or minus?
Yes. Alright, let's... Oh, I need to go back. Okay, 2/3.
I had to erase the previous. been a while since I wrote.
Yeah, I forgot how to write.
I forgot how to write. That's great.
You know, the break I was talking about how good you were, because I didn't know how to use.
I ain't even bring it up. You're about genius, not bringing it up.
All right, square root of 36 is the first one I've got here. What times itself equals 36? 6 or negative 6 also, so that's plus or minus 6. Shh. This one now they put a negative out in front. So I'm going to take the square root of 36, which is positive or negative 6, but then this negative out in front tells me they only want the negative. Okay, what about this thing? Not real. It's going to be 6i later on, right? Y'all remember that from Algebra 2? But today it's not real.
This wasn't a good video.
All right, this says the square root of 15 squared. The square root of 15 squared.
15.
Very good. The square root and the squared just cancel out. Simple on that. Okay. This one says the square root of negative 12 squared. 12. Okay, that's when you square that, that would turn it a positive, right? Now, when you have a variable underneath it, there's a rule that we got to write here. If I'm taking the nth root of a to the n power, okay, if n is an even root, if I'm taking an even root, so 2, 4, 6, 8, it's always going to have to be the absolute value of a. Okay? So when it's a variable underneath there and your n was an even number, it'll have to be the absolute value, which I didn't write that here. Why didn't I write that here? What's the absolute value of 15? 15. So when it's a, you don't have to include those bars except for when it's a variable, when you don't know for sure. Okay, so if I asked for the square root of y squared, you'd have to say that that's the square root of y. No, I said that wrong. The absolute value of y. So it's the same thing as what you did. You just got to throw those absolute value bars when it's a variable. All right. Look at a few more, and then we got to graph a couple of them. Got the fourth roots of negative 5 to the fourth. Then we're going to look at the fifth roots of negative 5 to the fifth. And we're going to look at the negative sixth root of negative 3 to the sixth. We're going to do the negative fourth root of m to the eighth. Oh, those are different. I'm going to do the cube root of x to the 24th. And then the sixth root, last one of these, of y to the 18th. All right, so we got six root problems there to look at. On number 1, the fourth root and the fourth power, what happens to those? Cancel out. So what's my final answer going to be? Positive 5. Very good. Okay, what about here? Fifth root and fifth power.
Cancel out.
That cancels out. But is it going to be a positive or a negative 5?
Positive.
It's going to stay negative.
Why is that?
To the fifth power,
Oh yeah. That's,
odd stays negative on that. So that we'd have a positive 5 there and a negative 5 there. All right, now this one threw the negative out in front of the whole thing. It's a sixth root, so that turns that 3 to a positive because 6 is an even number.
And there's another negative.
But then there's a negative out in front of here. So it'd be negative 3. Alright, now these down here are different because they're not the same, so they don't just cancel completely out.
Negative m to the fourth, maybe?
Nope. It is negative m to the
Oh,
second.
okay.
Now, a couple of ways you can get that. The easiest thing to do is if they're divisible, you just divide. 8 divided by 4 is 2, so you're looking at that. The way it works mathematically, since this is the fourth root, I want to write those m's with fourth powers, so that's m to the fourth and m to the fourth, because 4 and 4 makes 8, right? The fourth root of m to the fourth is m, and you got 2 of those, so it's squared like that. If it's divisible, though, that's the fastest thing to do, just 8 divided by 4. Okay, so what about this one? The cube root,
X to the third, or to the eighth.
x to the 8.
Third, y to the third.
Okay, and on this one, Austin's saying y to the third. I would think, I got to tell you, you got to add something on this one. Good, Bailey, absolute value, because it's an even root.
What happens if it's not divisible? What do you do? Put it in fraction.
No. Let me see if we have one of those today. I don't think we get to that today. We'll do one. Let's look at, just because we're talking about it, let's look at the sixth root of y to the 19th. Okay, Austin asks, what if it's not divisible? 19 divided by 6 doesn't go evenly, so it's not a whole number. So what you're going to have to do then, since this is a sixth root, we want to rewrite this with as many 6 powers as we can. So there's 18, but I got to go to 19, so I would have 1 y left over. Okay, then the sixth root of y to the 6th is y, and you've got 1, 2, 3 of those, so it would be cubed. Then this thing, if the power, that's an understood power of 1, right? If the power is smaller than the root, it stays in the house. So that would be your final answer. We'll get into that more later, but I just wanted to show you while Austin was asking. Alright, want to look at a couple of graphs. I got what you need there? Alright, we got f of x, remember that's the same as your y, is equal to the square root of x plus 2. Now, what are those radical? Square root, radical graphs, square root graphs are kind of like half parabolas to me. That's what they remind me of, their shape. They're going to be sideways most of the time though. What you've got here, if I start making an input-output table on this, if I plug a negative 2 in for the x, negative 2 plus 2 is 0, and the square root of 0 is 0. Okay, what happens if I plug a negative 3 in for the x? Negative 3 plus 2 is negative 1. What's the square root of negative 1?
Isn't it I?
It's I. It's imaginary, so I can't have anything to go with negative 3. So that means the smaller I go, if I plug a negative 4 in, that's also going to be an I. So I can't have anything smaller than negative 2. So now I'll go the other way. Negative 1 plus 2 is 1. The square root of 1 is 1. 0, that's not going to give me a whole number. I'm going to stick with whole numbers. So 2 would be my next one. 2 plus 2 is 4. Square root of 4 is 2. So if I look at graphing those there, I've got negative 2, 0. Negative 3, we couldn't graph. Then I got negative 1, 1. 2, 2. So that'll be like a sideways half parabola going through there. And now what you're going to be asked about on these are domain and range. Domain is your x's. It's what you do left to right. We know we can't be smaller than -2 because that would make it imaginary. So my domain has to go from -2 to infinity. What about my range? Does it ever get lower than this? No, so it would go from 0 to infinity. Now you could type all that into your calculator, so you can graph it in the calculator if you don't remember how to do your input-output table. We're doing with the odd root next. Make out what you need. Alright, this one says f of x is equal to the cube root of x minus 1. Now, when we're doing an odd root, 3 is an odd number. When we're doing an odd root, can we have negatives underneath there?
Yeah.
Yep, so we don't have to worry about what not to plug in. So let me see some perfect cubes. I know I got a 1, an 8, 3 cubed is 27. Well, I'm not going to want to go all in. Alright, plug a 0 in. 0 minus 1 is -1. The cube root of -1 is -1. I can plug a 1 in. 1 minus 1 is 0.
0.
Cube root of 0 is 0. I could plug a 2 in. 2 minus 1 is 1. Cube root of 1 is 1. Plug a 9 in. 9 minus 1 is 8. The cube root of 8 is 2. I need to get some negatives, though, so let's see. What could get me in -8? -7. -7 minus 1 is -8. Cube root of -8 is -2. What'd you say, Austin? Oh.
I forgot what he said.
I don't think I can. I already got this.
-29 or 7.
Yeah, -26 would work, but I don't want to count that far. So let's just plot these and see what happens. 0, -1, 1, 0, 2, 1, 2, 4, 6. Oh, I did those on ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 1, 2. Alright, so you see it's going to kind of go up there and then level out to hit that one and then level out down here to hit that one. My description of cube roots is it looks like a snake. So there's my snake graph on that. Should have gotten something similar to that on your calculator if you did it that way. Okay, what would the domain? Domain and range are easy on odds. What would the domain and range be? Good, -infinity to infinity on both of them. And that is it. Alright, we are going to stop it there, and tomorrow we'll get into rational exponents. That just means the exponents are fractions. So we'll get into that mañana.